All right, Heather and Jerry standing on a bridge. Boop, bridge. That's my bridge. And the bridge is 49 meters. And they're going to throw a rock straight down at 16 meters per second. Hold on, there's a rock straight up. So you've got two options. One's throwing it up at 16 meters per second, and one's throwing it down at 16 meters per second. How much time elapses between the first and the second splash? So what you're going to have to do is solve for time twice, right? So you're going to use the equation y2 equals y1 plus vyt plus 1/2 at squared. And we could figure out all this, but we know the y1 is 49 and the y2 is 0. So that's going to be 0 equals 49 plus, and actually if this is 16, this is negative 16, right? Plus, let's say negative 16t plus 1/2 times negative 9.8 t squared. Use quadratic formula to solve this problem, and I get t equal to 1.9 seconds. Then you repeat the same experiment, or the same deal, except instead of negative 16, you have positive 16. So you do the exact same thing, except this becomes positive 16. And on that, the second case, I get t to be 3.3 seconds. We have two different times. So to find the difference, you'll just take 3.3 minus 1.9. That gives you, pardon me, this is not 3.3. This is 5.19, and then, or 5.2. And then if you take 5.2 minus 1.9, then you get 3.3 seconds. So that's the answer to the question. Which rock has the faster speed as it hits the water? Now you could actually calculate that going, with initial speed and final speed and all that business using v2 squared equals v1 squared plus 2ad. So you can totally do this, but I would recommend that you don't, because the reality is the speed going down is negative 16. As you throw a rock up and it turns around and comes back down, because it's falling, it's going to have a negative 16 meters per second. So they're going to both hit at the same speed. So it didn't ask me to find this speed, but if you calculate it, you would find the answer was the same in both cases.